Hello, everybody. We're still working on our absolute value, and today we're going to touch on graphing absolute value functions. Now, when we get into class, we will be working on these in the graphing calculator. So if you take a minute to fill this in. And we are going to fill in our absolute value table to start with. The absolute value of -2 is 2. The absolute value of 1 is 1. The absolute value of 0 is 0. The absolute value of 1 is 1. And the absolute value of 2 is 2. And so you will see these plotted here on this graph. This is called the parent absolute value function. It's called that way because we haven't added, subtracted, multiplied this by anything. Once we start doing that, we're doing something called transformations. We're transforming this function. It still is absolute value. It will still have a V shape with two straight arms, but it'll slide around the graph. The arms might get narrower or wider, and it might flip upside down. The domain is always going to be all real numbers, and the range for now is going to be y is greater than or equal to 0, because remember, y is equal to 0 here on the x-axis, and our graph is only going above that. So if we take a look at this very first example, the absolute value of x plus 3. This plus 3 means that we are going to add 3 to all y values. And we add them to y rather than x because that plus 3 is not directly touching x at all. If I go back to that xy table of our parent function, so I'll call it P, then I would do the y values plus 3. And so our new table, we haven't changed these x ones. 2 plus 3 is 5. Sorry about that. 5. 1 plus 3 is 4. 0 plus 3 is 3. 1 plus 3 is 4. And 2 plus 3 is 5. Now when I plot this on our graph, we have -2, 2, 3, 4, 5. -1, 4. 0, 3. And here's our graph. Inside here, this -2 is touching x. And we've talked before a little bit about the fact that x's do everything opposite. It's always opposite day for x. So whatever is attached to it, it's going to want to do the opposite. So because our x is here and it moves left and right, then this is going to move our graph left or right. And remember, it's always opposite day for x. So if this says -2, it really means it's going to go right 2. What that means on our table, again, we're looking at this parent function. And this time, instead of the y, we are changing the x. So here's our parent. And we're going to do plus 2 here. So 2, 1, 0, 1, 2 has not changed. Negative 2 plus 2 is 0. Negative 1 plus 2 is 1. 0 plus 2 is 2. 1 plus 2 is 3. And 2 plus 2 is 4. So if I graph that on our grid here, and there's our graph. Remember, we're always using that same parent function. We're going to skip over those U-tries. We're going to use them tomorrow in class for the graphing calculator. Pause for a minute and take down this information about stretches and reflections. Oh, shrinks. All right, so if I'm looking at A, this 2 in the front here, because 2 is more than 1, means that this is a stretch. It's stretching the arms of that parabola up towards the y-axis. Remember, the y-axis is here, so it's getting closer and crowding that y-axis. What does that mean for the points that we're working with? Well, again, here's our parent. Remember, this parent never changes. What it means is we are multiplying the y values by 2. Now, remember I said in the last one, if it's not directly touching x, then it's not happening to x. It's happening to y. And so in this new one, these are still the same. But I'm doing this. 2 times 2 is 4. 1 times 2 is 2. 0 times 2 is 0. 1 times 2 is 2. And 2 times 2 is 4. So if I'm using these new ones, we're here at 0, 0, 1, 2, 2, 4. And so there's our new graph. And you can see that it's closer to y now. The arms are closer to y versus this was our parent function. So these arms right here came closer to the y-axis. I'm looking here at that negative 1/2. So the negative is a reflection on the x-axis, which means it flips upside down. The 1/2 is between 0 and 1, and so this is a shrink. Again, starting with our parent, x and y. We always work our transformations from left to right. And again, this x is tucked away inside that absolute value. So that means that everything that's happening is happening to y. So we start with making y the opposite sign. So this is negative, negative. 0 can't be positive or negative, so we can't change that. Negative and negative. After that, we're multiplying y by 1/2, or taking half of it. So half of negative 2 is negative 1. Half of negative 1 is negative 1/2. Half of 0 is 0. 1/2 and 1. So what that looks like on our graph, let's make it this darker color here. is it makes it look like that. See how it's shrinking away from the y? Here's our y-axis right here, and it's shrinking away from it. All right, leave 3 and 4, please, for next class. And we're going to come to this last part, which is vertex form. Vertex form is when they already give you where that vertex is. Now, the vertex is the pointy part. Doesn't matter if it's right side up or upside down. The vertex is the pointing part. Vertex is kind of like a turning point. It's where it changes direction. This one, when we're graphing, we're going this way, down, down, down. And then when we hit that vertex, we change direction, go up, up, up. If it's upside down, we're going up, up, up to graph it. And then when we hit that vertex, our pen starts going down, down, down. So the vertex is HK. Remember, it's always opposite day in X's world. So that's why when that says minus H, it's a positive H here. And so let's take a look and see what happens. Your paper should already have this adjusted to be 2x plus 2 minus 3. So remember, opposite day, always, always in the world of X. And so that's a negative 2 and then negative 3. And so that means that on our graph, we have negative 2, negative 3. And then remember, we're going up 1 over 1, up 1 over 1, up 1 over 1 to graph that. And so there's the first graph. For the second graph, it has that same vertex of negative 2, negative 3, but this time we're stretching it. We're stretching it towards y, or together, by 2. And so we have the same thing, but we're doubling and doubling. And there's our new graph. All right, this is where we will pause. The rest of this we will work on in the graphing calculator. Thanks so much for joining me today, everybody. Have a great rest of your night.